Pre-calculus, notes 8.4, we went from 8.2, we're jumping and doing one kind of problem on 8.4, and then we're going to use that in 8.2. So we are going to be looking at the determinant of a square matrix in 8.4, but before we get to that, we have a warm-up here just to review multiplying matrices. And so we've done it in class, and so if you've done it in class, you can just skip over this and go to the other notes. When you multiply matrices, we want to look at the dimensions, and it goes row by column. So in example 1, which is your warm-up, it's a 2 by 3, and B is a 3 by 2 matrix. And in order to multiply them, these two dimensions must be the same, which they are, and then your ending result is the outer dimension, so your end result should be a 2 by 2. And so when you go to multiply these, you take this first row and multiply each corresponding element with this first column. And then add those up, and you will get your first element in your product matrix. And so that A times B looks like, we have -1 times 3 plus 3 times 1 plus 4 times 0, which is 0. So your first element is going to be 6. Then we move over to the next column, and we multiply corresponding elements. So we have a -1 times -2 is 2, 3 times 2 is 6, and 4 times 3 is 12. And that is going to be your second element in your first row. We've run out of columns, so now we are going to go back and switch the row on the first matrix and go back to the first column on the second and multiply corresponding elements. 0 times -3 is 0. -2 times 1 is -2. And 6 times 0 is 0. Then we're going to move to the next column on the second matrix and multiply corresponding elements again, and we have a 0. -2 times 2 is a -4, and then plus 6 times 3 is 18. And then just simplify those, and notice we're going to end up with a 2 by 2, and we get 6, 20, -2, and 14. And that is your product. Now, every square matrix, and a square matrix is defined that the size, the number of rows and number of columns are the same. So it's a 3 by 3, 2 by 2, 4 by 4. And every square matrix can be associated with a real number called its determinant. So it's just the end value of a determinant is a single numerical value. And so here we have matrix A. It is a square matrix because it is a 2 by 2 matrix. And the determinant denoted like this. And it looks like it's absolute value. You'll notice that when you are being asked for the determinant, the brackets change to just these straight bars up and down. And sometimes, just due to lack of having a math type or equation editor, you'll see that a determinant asked for where they have the square brackets, but technically when they put straight brackets, then they're asking for the determinant. And the value of the determinant is simply take this diagonal, multiply it, that's A sub 1 times B sub 2, and then subtract the product of this diagonal, A sub 2 times B sub 1. And you evaluate that and you have the determinant. So in this first one, the determinant of this matrix, we're going to take. So the determinant, we don't have a name of it, so the determinant is going to be your 5 times your 1, and then minus this diagonal, 5 times a -3. And so you get 5 plus 15. Oh, I wrote down 5, and that's supposed to be a 2, sorry. So 5 times 1, and then 2 times a -3 is going to be a positive 6. And our value of our determinant is 11. All right, so in part B, the determinant, you can pause it and try it on your own. It should be the product of this diagonal, that -6 times 0 minus the product of this diagonal, which is a 1/3 times a 1/2. And you get 0 minus 1/6, so the value is a -1/6. And it's as easy as that for a 2 by 2. And to find the determinant of a 3 by 3, there's more to this if you want to get to larger sizes, but there's kind of a little trick way to find the determinant of a 3 by 3 matrix. And so when I want the determinant, notice I have the straight bars. We copy the first 2 columns over again as we go to the right. And then what we're going to be doing is we are going to be taking the product of the down diagonals, and I'll show you what those are, minus the product of the up diagonals. So I'm going to start with, I'm just going to use some different colors here. We have this diagonal going down, and we take the 1, the -8, and the 3, and we multiply those. So the 1 times -8 times 3 is a -24. Then we take the second down diagonal, the product of those 3 numbers, 2 times 1 times 2, which is 4, and add that. And then we take the product of that third set of diagonals with 3 numbers, 3 times 5 times 4, which is 60. Then from that, we are going to subtract the product of the up diagonals. And so for the up diagonals, we are going to start at the bottom left corner and diagonal up and take 2 times -8 times 3, which is -48. And add to that the second up diagonal, product of those 3 numbers, 4 times 1 times 1, which is 4. And then add to that the product of your third diagonal, up diagonal, 3 times 5 times 2, which is plus 30. Oops. And then just do the math. You get 40 minus, this comes out to a -14. And so you get 54. And so the value of the determinant is a single numerical value. So you could pause this, try this on your own, see if you can remember the process on this next determinant. And so, well, how'd you do? Start by copying the first 2 columns. Then we have the product of the up diagonals. So we have, the down diagonals. We have 5 times 9 times 0, which is going to be 0. And then switch to the second down diagonal, which is 0 times -2 times 1, which is 0. And then plus the third down diagonal, which is 24. 2 times -3 times -4. Then from that, you're going to subtract the up diagonals. 1 times 9 times 2, which is going to be 18. Plus then that next up diagonal, -4 times -2 times 5, which is 40. And then the third diagonal, 0 times -3 times 0 is just going to be plus 0. So you get 24 minus the 58, which is a -34. That's it.